Yeah, there we go. Hey there, welcome everybody once again to Astronomy Daily Live. So hope everybody's doing well out there in the universe and the world. So this is a daily um, gathering together of friends each and every day to come together and just spend an hour or so, talking astronomy and space and science and all kinds of nerdy things, Star Treks and Star Warses
Actually, we're not gonna. I'm not going to do
telescopes
Star
and
Trek
observatories and cameras and
astronomy stuff.
binoculars and stars and galaxies and clusters, nebulae, all of it. And what is it doing here? Why is it here? You know, uh, what are these things? Just so many questions, so many, and I sort of base my thoughts around all of these things on sort of three main things. I'm gonna show off what cool. So Atta has the Backyard Astronomer's Guide.
This is really
Excellent.
good.
Still can't hear you, Atta. Still can't hear you.
I don't get this. I can't figure out why.
That's just no good whatsoever. So
Atta, can you hear me?
work that out slowly.
Let's see here. I'll mess around with this for a while, but this is getting a little
here.
Okay.
See what's going on. Hey
I'll
there,
try
Tom.
the earphones.
Nice to see
Can you hear me?
Uncle Bill. Yeah, the Obs-Session is not canceled. It's just I once again got my timing down a little bad, so I wasn't able to take any cows. So as you can see, there's no telescope here. It's outside cooling down. Got another roughly about another hour and 20 minutes or so before it's dark. And Uncle Bill is saying, don't change anything, Atta. Don't change anything. So I don't know what that means, but because I think she's going to have to change something if she wants to be employed. So yeah, don't know what's going on there. Oh, you know what? I think it's me.
Well, I would hope it isn't me.
I think it's me. I do not have my headphones plugged in. Oops.
Yay,
All
you
right.
can hear me. Great.
Here we go.
Hey, Cosmic!
Yay, I can hear you, Bobby. Atta, say something.
Yes, I have this up here. What you didn't hear, this Backyard Astronomer's Guide is really good for beginners. Now, I know that you say this program is for everybody, but I really wouldn't even be here if it weren't for my background in science. I couldn't follow what you were saying. But this is a good background for beginners, a great book for beginners. And the only thing I'm going to say about Star Trek tonight is Nat Geo puts out a book. It's called Star Trek, The Official Guide to Our Universe, the true science behind the Starship voyages. And this is really, really good. I've been waiting for this for quite a while, so I may go underground and read the thing from cover to cover.
Nice.
And before you totally get into the data, wait a minute. Aha! Today, what arrived in my astronomy toolkit is a device called a Celestron focus motor.
Yes.
I haven't even taken it out of the plastic wrap yet. everything you need to install it comes with it. They even included a little Phillips head screwdriver.
Wow.
And this thing operates. This is supposed to take the fuzziness out of focusing, among other things. You actually have to install it on your system. It'll work on all the Schmidt-Cassegrains and most of the Celestron telescopes, but there's one odd one it won't work on. I think it's the 9 or 9.5 inch HD, Nexstar HD. Now they're going to fix this, I'm sure, but it's the only one in the whole line that it won't work for. But I can't wait to try it. And if it ever clears up in my area, I will be out there trying this thing to see how it works. I mean, for the kind of stuff I do, it's not all that necessary, but I love gadgets. This is one of the reasons, Bobby, I'm on hold for radio right now. I've got too much astronomy tech coming into my life. I just don't have time for any more.
Nice.
Well, that's okay, Otto. That's okay.
I'll be sure to let you. I'll be
Yeah.
sure to let you know how that works when I try it.
Yeah. So, does that actually fit onto? I'm gonna. You take the focusing knob off and you put it on the focusing knob.
Yes.
Yeah.
You really remove your old knob and you replace this with it. Yeah.
And then where does that plug into? Does it plug into the computer or does it plug into the telescope?
It plugs in. You can plug it in anywhere you like, depending on what your system is.
All right.
But where I'm going to plug it in is into the base of my scope. On my Nexstar Evolution, the battery is built in, and it's got a whole bunch of auxiliary ports. So I'm going to plug it in to one of my auxiliary ports. Oh, what you see back there is a whole bunch of fur coats. I used to sell furs, and I got them for a discount.
Wow.
And for you animal lovers out there, as I am, I couldn't do anything for these. They were already dead, you know.
Yeah.
So
too late.
Here we are. And this device basically
You're gonna get sued by PETA. You're gonna get sued by PETA.
Now, they've tried to kill me on numerous occasions, but they thought better of it when they took me on.
Yeah.
I used to work on, just as a short aside, I used to live on a game preserve in South Africa.
Wow.
And every year we took out hunting safaris, and we would tell them which animals they could shoot, which are usually the big old bulls. They make the best heads. Now, what we did with that money was see to it that those animals had food and water during the very, very dry South African summers. There were many animals that, if left to their own devices, would have had no chance to survive if it weren't for preserves like this. And I know from being involved with preserves that the largest killer of animal life on this planet isn't poachers. It's not people who wear fur coats. It's none of that stuff. It's people who live in houses where they have more butts. They have more toilets than they have butts to put down on them. And they're using up gobs and gobs of resources.
Huh.
There, I've had my say.
Yeah.
Thank you.
That's
Yeah.
And I couldn't agree more. Yeah, that's absolutely true. So
don't get me wrong. I'm not advocating killing things. I'm just saying that many times, if you use far more resources than you really need, you're taking them away from something else. I mean, that just makes common sense.
Yeah. It goes back to the responsible use.
Yeah, that's it. I mean, you can't keep living on 10 times what you need, or something's going to suffer. And of course, it's animal life that does.
Right.
But anyway, I thought I would show you my latest latest
Nice.
image here.
Nice,
And
nice, nice.
And by the way, it's controlled. Once you plug this thing in, you control it using the handheld controller that
Right.
comes with your scope. There isn't a separate control for this. Some people don't like that, but personally, I just as soon control everything from one controller if I can.
Yeah, that makes it a lot easier. Now, is there any kind of like autofocus on that, or is it just all? Is it going to monitor the focus to make sure that you stay?
Yes, at least it's advertised to do that.
Nice, nice.
So that should be good. We'll see. I mean,
Excellent.
I don't do anything that complicated. I wish Carolina were on here. He'd probably get a lot better use out of something like this than I would for the kind of work he does. You know, he does great little videos that he puts up of the planets and stuff. And
right.
No, he does really. You know, he does really good videos considering the equipment he's got. I mean, it's not bad, but it's basic equipment.
Right. Yeah, you don't need really a lot. It comes back, to the bowling ball thing. It's what gets you the high scores? Is it the ball or is it the bowler?
Yeah.
And for the most part, until you get really, really, really high level, it's really the bowler. Really, really, really. It's just that last little bit where the ball starts to make a little bit of a difference.
Oh yeah.
And it's exactly the same thing here. So you don't have to have the most expensive equipment. You don't have to have the best in the world. You can do really, really well with not much.
I agree.
Depending on what you want to do, you're going to have a minimal setup. But once you have that, you can do really, really, really well. And that's part of the project that I'm working on is characterizing that, seeing how well sort of an average system works. Because if I can make that work really, really well, when and if I get anything better, all things are going to improve. So yeah, absolutely. And to have that kind of control, with the focus, it's nice.
It's nice, but again, Carolina probably doesn't need it, but he would benefit by something like this more than I, because I'm not doing, I just go out and observe,
Right.
I don't do anything cute. I don't make movies.
You just wait. Once you get into photography and all that, you might get the bug and it's like, man, I've got to do this.
Yeah.
So you never know. And lots of people like to do the photography. It's not, that again is a lot like the bowling analogy. That you can do really, really, really well. You don't have to be perfect, but it's pretty easy to do some really, really, really nice stuff. So yeah. If that's the direction you want to go, that's a great one. If you just want to be looking, that works well there too. So yeah, excellent. All right, well, great. Well, yeah. So I am going to be going out observing. I'm still waiting for the wind to calm down a little bit here. So I'm looking outside at some of the trees, and they're still moving around quite a bit. So at this point, it's a no-go, but I've got another hour-ish or so before I really have to get going. It's going to be HW Virginis again. I'm going to try to catch the primary eclipse and the secondary eclipse. The primary eclipse. Let me look at my list here. The primary eclipse is supposed to start at 4:08 UTC. It's supposed to be in the middle at 4:18, and it's supposed to end at 4:28. So what I want to do is I want to start collecting data like around 3:30 UTC. So that's in about an hour and 15 minutes from now, and go to about 6:30. So I'm going to do about a 3-hour run on that thing, looking at the same stupid object for 3 hours.
Yeah,
and
that's okay.
No, that's how it is. So
I just can't wait for Check Me Out on Twitch to finally finish next month.
Yeah, she's in school and she's got 1 more month to go, huh?
That's it, and then
Nice.
she's gonna get that degree or something.
Yeah.
And I don't know. She might even do it every day if she wants to.
Yeah. Well, she's making sure that she has lots of choices, and I am totally into that. That's
right.
One of my biggest things is maximizing choice, and then you can choose. If you only have one choice or two, then it's like, well, okay, I have to do that or that. But if you've got 100, it's like, man, I'm gonna get the best of the best. So yeah, I'm looking forward to what she's going to be doing in the future, and yeah, I think she'll do great. Sound is excellent, and yeah, and is underrated. Lots of people sort of greatly appreciate sound, in terms of music and all of that. But there's a lot of things going on with sound, I think, inside of our heads that we're not really all that aware of.
I mean, I like her sound. I like her sound meditations. But I'll tell you, I look at the chat that's going on while she's doing these meditations, and I must be getting old because I don't get it. I look at these, and I use this term loosely, conversations people are having, and I'm not getting any of this. I mean, I just shut my eyes and I do the sound thing.
Yeah.
I don't participate.
Yeah, that's it.
This kid knows what she's doing on homeopathic medicine, sound, what sound does for the body. She's no quack. I support her because I respect her technology. I respect her approach to this.
Oh yeah.
Yeah. And it just makes me want to think. Sometimes I wish I could just let me try to do some meditation, like after church. It's just like every time after church, I have to go somewhere else. It's like,
yeah. Well, once you practice meditation a little bit, Bobby, you'll find that you can actually meditate anywhere, anytime. You don't have to have any kind of ritual or anything, to do it at all. You can do it actually while you're speaking, the whole thing. So yeah, it just takes a little bit of practice and stuff. And the sounds, they definitely allow our minds to kind of focus on one thing instead of 10,000 thoughts. I think there was some kind of stat that said that we have like 40 to 50,000 thoughts every single day. and that would be okay, but they're the same ones over and over and over and over and over and over and over again. So meditation and listening to sounds, or doing some kind of mantra, that sort of allows you to quiet the mind down, by focusing on basically just one thing. Instead of having thousands and thousands of thoughts, you have one. And then the leap is then to go from that one thought to zero thoughts, and then it gets extremely interesting. So
and you know what else? I sometimes wish I could just take it back, because did you not know that tomorrow, local and Anta's, mine's, and yours, Cosmic, is Easter?
It is Easter Sunday. Absolutely.
Andy, you probably are already celebrating Easter right now.
Well, I guess in a certain way, yeah. I suppose I am. Yeah.
No, I'm talking about Andy, because he's across the pond.
Oh, Andy. Pond. Oh, okay. All right. I thought you were mentioning me. Is Andy in the chat?
Yeah.
Oh. Yeah. Hey there, Andy. Great to see you. Yeah. Nice. So that's sort of the plan for tonight. As I said, still looking at maybe a little bit of wind, but we'll see how it goes. I really want to see this whole thing. So that's sort of the primary goal. And also to collect some more data on these things. Every single one of these is sort of unique in its own way. So and you never know what might transpire, right? You might see something that has never been seen, or rarely seen. So yeah, worth doing. I suppose so. I've got a lot of data right now, so I mean, I don't necessarily need any at the moment, but it's clear, and the moon is, well, it's going to be there, but it's not going to be incredibly close. So yeah, might as well. And I mean, it's not cold anymore either. So that makes it extremely enticing to get out there. Just got to get the wind to not be a blowing all that much. So all right, well, I've got a little bit of this hydrogen hydroxide left. So very good. Cheers to that.
Just opened up a freshly new bottle of water.
All right. Excellent. Well, so I thought this is going to be a little shorter live stream than normal, because I'm kind of itching to see what's going on with the wind out there and all of that.
From the other side of the world going down, not left or right, okay? There's Ingrid.
Well, that depends on your perspective, right? I can't hear you, Bobby. You're breaking up. Ingrid, hey, nice to see you. She was in there earlier. She posted the first chat, like almost an hour ago or so. So yeah. All right, excellent. So yeah, I thought what I would do. Let's just. Oh, by the way, so a number of years ago, and I'm trying to remember when it was. I could look, but I did for a number of months I did a podcast for the 365 Days of Astronomy, and I did that for just a few months. Called it um, 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 the Apogee Podcast, and as sort of the name implies, it came out at or near the apogee, when the moon is furthest from the Earth. And I would just, talk some kind of astronomical thing. It was like a 20-minute, 25-minute thing. It was really, really short. Usually I would just find a really, really interesting paper, and just sort of expand on it, go through it a little bit, sort of what we do here. But I would actually study the paper and talk about it, and that, yeah, I started getting really, really busy. So even that, just doing it once a month, there was so much prep work. I had to read the paper through, and because of the density of this head, I'd have to read it through, 3 or 4 or 5 times to really, really, really understand what it was saying, and then I would have to write a transcript.
As I was saying, from deeper than deep south all the way to Brazil. Hello, Ingrid.
Hello, Ingrid. All the way from Brazil. Sao Paulo. Yeah, she's near Sao Paulo, if I recall. Yeah, very, very cool. So anyway, that is something I did. I want to say back in 2012, 2013. I forget exactly. I can't believe that it's been that long, but I think it has. And I decided that I'm going to jump back on that a little bit. So I contacted them and said, "Hey, do you want to revive the podcast?" And they said, "Sure." So yeah, I think that's going to be starting up here, probably not this month, but next month. And the apogee for May is something like the 25th or so of May. So the podcast will be right around that date. So I'll of course keep you all informed on that, and let you know how that goes. But yeah, I think that is something that I can definitely do. My my time at the moment, at least, is a little bit more free. So I've got extra time, I guess you want to call it that. That I can definitely devote to that. So yeah, coming soon, back on 365 Days of Astronomy, I will be doing the Apogee podcast once again. So yeah, I think that'll be a little bit fun. I don't really know what I want to do with it. They're pretty much open, to anything. So they're just really, really glad to have contributions. So that means it's up to me, to sort of decide, what to do. And so at the moment, I'll sort of keep the same format. I'll spend a couple weeks trying to find an interesting paper of some sort, some line of research or something, and I'll study the paper, and I'll study the topics a little bit, and then come out with the podcast. So yeah, that'll be somewhere around. Well, first one will be somewhere around the 25th of May. It might be the 24th or the 26th or 23rd, somewhere around there. Because they already have slots filled. So um, the podcast may not actually come out on the Apogee day, but that's okay. They rarely did when I was doing it before anyway. So, all right, well, that's the big announcement there. Um, nice conversations in the chat. I like it. So yeah, I think what I'm going to do is let's just run through the Friday edition of archive.org. That's arxiv.org. So they come out.
Ingrid never heard of Talladega Nights, but my college friends used to call me Ricky Bunny.
Okay, cool.
From the Wonder Boy, Bobby Boucher.
That's nice. Very cool. So yeah, let's just go through these and see if there's any titles that sort of grab the interest of either the panelists here or myself, or anybody in chat. Just yell out if there's anything particularly interesting. So let me get this set up. So, I think I've already got it set up. Yay! Wow, I actually had some forethought there. That's pretty amazing. So, all right, let's. I'm going to share my screen then, and let's take a look at the latest. So, these come out. These are the latest scientific journal papers that have come out.
Hey, you hit the stop button.
Yeah, I did. There we go. There we go. So there it is. So yeah, these come out every weekday around maybe 1 or 2 UTC, something like that. And of course, astrophysics is right at the top, as it should be. So they were extremely wise to put it at the top. So let's look at this past Friday's entries here, and there's usually 40 or 50 or more new papers every single day. So I sort of call it the bleeding edge of astronomical research and thought, and it more or less is. Although many of these papers take months or years to write, and then it takes weeks or months to actually get them through the machine to get them published. And once they're accepted for publication, they can sort of go on this list. So let's see if there's anything interesting here. Jet cocoon outflows from neutron star mergers. Accurate description of an accretion-induced collapse. Disk tearing and Bardeen-Patterson alignment. Wow. So, I would say 95% of these papers just fly way over my head. But that's okay. I don't see anything wrong with that at all. I don't necessarily want to read about things that I already know. So, I'm looking for, really, really interesting things that I don't know. So here we go. So this is probably a pulsar of some sort. That is usually a designation of a pulsar. Yeah, in this case it is. So it's a pulsar going around another star. Wow, okay. pretty crazy. Dark matter strikes back at the galactic center.
That's a nice title, catchy title.
That's yeah.
Dark matter strikes back at galactic center. I like it.
I like it. Well, you know what? We're gonna have to look at it then.
Becky has some pizzazz.
Oh, it looks like a big paper too. If it loads slowly like this, it's usually really, really big.
Maybe I ought to skip that one.
It could just be that my internet is slow, though. Who knows? I don't know. Let's see.
She just had a ponytail, so that's why you don't see the spunk ears.
Yeah. Oh, okay. So 39 pages long. So that's a pretty sizable paper here. So let's see. They're coming out of Cambridge and Princeton.
And PSK just went live with, I think we're looking at landing moon tonight.
Cool. Nice. Yeah, I'm sure the moon is up over there. They're over on the East Coast, so they're 3 hours ahead of me. So yeah, the moon is probably up over there.
Was asking Atta, where are your Spock ears? And I noticed about the hair. She doesn't have that ponytail that shows her Spock ears tonight.
Yeah, they must be, hidden underneath.
Yeah, I don't want to let any of you know that they're real.
No. You don't want that. You don't want that. Because people will start talking. And
they already do. Even without the ears.
That's great.
I mean, try to consider where I live. I'm a little outside the curve in an old age home. I'll tell you that.
Well, that's okay. Keeps everybody sharp.
I don't mind. Heck with it.
Yeah. So statistical evidence has previously suggested that the galactic center giga electron volt excess originates largely from point sources and not from annihilating dark matter. Okay, we examined the impact of unmodeled source populations on identifying the true origin of the GCE using Guisanian template fitting methods. So yeah, this is totally a model of some sort. So yeah, that's a lot of energy. Billions of electron volts. That's a lot. But I guess previously we're talking about it coming from point sources, but it looks like these folks are maybe suggesting that it's so-called dark matter. It may provide a dominant contribution after all. Oh, okay. Yeah. Well, it's a provocative title, but wow, this is gonna fly way over my head for sure. Yeah, it looks like it's all just based on models. I'm sort of looking here, seeing some Python code. Okay, well, let's. I wonder if we have any chance at all of understanding these plots. Evidence that dark matter can be misidentified when templates used in the analysis do not accurately describe the data. We simulate bubbles, PSs, and disk PSs. Oh, I don't know what a PS is. It's probably, let's see, there's a PS. This is usually how you can find things. You can just sort of go back to where you first see it. So there's PS's. What is a PS? There's PS. Let's keep going back here. PS. It's got to be here somewhere soon.
Yes, yes.
Yes.
Yeah, this is pretty heavy. It's definitely written.
Here we go.
There we go.
Yeah. Point sources. Okay.
Point sources.
Point sources. Yeah, and you know, most of the people who would read this, you know, are just a specialized group anyway.
Oh yeah.
So yeah. I mean, that's why, you know, there's no reason to feel bad or intimidated or anything by this stuff. You know, if you don't understand it, you don't understand it. That's okay. Anyway, bubble point sources and disk point sources, and smooth DM, which I guess is probably dark matter, bubbles, isotropic, and galactic diffuse templates. Holy moly. So yeah, I'm not even going to try. I guess, the flux fraction is what they're talking about in terms of, the billions of electron volts. But this posterior probability, I don't know if I'm going to follow that much. But so here is, okay, so let's see if we can dive into this. There's 1, 2, 3, 4 plots. They're not, doesn't look like they're marked in any way, but they're definitely different. Not quite understanding exactly what the difference is, but here we go. So top left is 2% dark matter injection. I guess that's, I don't know if they're talking about this over here. I guess so. Oh, here, yeah, 2%, right along the dark line, the blue line here. I guess that changes other parameters depending on where this dark matter is injected. I don't know. Okay, yeah. So they're sort of the main difference, right? They're doing 2, looks like 5, 7, and about 15%. So okay, let's see. We show that the flux posteriors for analyses using the same templates as the simulated data, except the fit includes NFW point sources. I'm not quite sure what NFW is either. NFW, we should be able to figure that out too, huh? NFW. Oh, okay, so it's apparently a commonly employed prescription for the dark matter density profile. So, okay. I guess a density profile in terms of like radially out from a galaxy. That's sort of how I would interpret that. So, okay. Well, not bubbles, a smooth isotropic. So vertical dashed lines indicate posterior medians and 68% contaminant bands. So, whew, lots of stats, and yeah, I don't know about any of that. It's pretty involved, I would say. These factors. Yeah, wow. it's definitely the the papers that just describe observations are complicated enough, but the theoretical stuff is really, phew, mind-blowing. Flux posteriors when an artificial dark matter signal with increasing normalization is injected into the Fermi data. Conclusions and outlook. We have studied examples of how NPTF, I don't know what NPTF is either, non-something. Let's see if we can find out what NPTF is.
I think it was attracted to the wrong article here.
It's all right. It's all right. We, it's sometimes useful to dive into these things. So non-Poissonian template fitting. So yeah, it's just a means of trying to fit models to data.
Yeah, and I can see why they got into that, because I'm sure that dark matter is misidentified a lot of times, since we don't even know what it is.
Don't even know what it is. It's probably something else completely anyway.
Yeah.
So
I mean.
So all right, PDF methods can be biased in both real and simulated gamma ray data, and how this could impact the implications of the lots of energy that they're seeing there. The excess of energy that they're seeing. So we showed a proof of principal example in simulated data where a dark matter signal can incorrectly be attributed to point sources. Okay. Well,
okay. So on this day in 1972, Apollo 16 landed on the moon. Astronauts young and new collected 95.8 kilograms or 211 pounds of moon rocks and drove the lunar rover 26.7 kilometers or 16.6 miles while on the surface.
Apollo 16 landed today? Wow. Nice.
In 1972.
Yeah. I think they were up on the moon for at least a couple days, right? I think that's how that worked out. So yeah, wow. So all the rest of this is supplementary material. So look, like what 4/5 of the paper is describing how they did it, and there it all is, and all the gory details. A little bit of calculus, a little bit of matrix algebra there.
They spent almost 3 days on the moon. Well, 71 hours. 1 hour away from 3 days.
Wow. Yeah. Pretty amazing. Pretty amazing. Well, hopefully we'll get back there eventually. So yeah, that is an intriguing title. But wow, that's about as far as I can get into it too. That's
too heavy. The girls are too smart for us.
that's some pretty heavy stuff, for sure. So yeah, absolutely. When it comes to research and thinking deep about these kinds of things, gender plays absolutely no role whatsoever. We just have to make sure to get out of each other's way, right? So there's no suppression. That's ridiculous. All right, let's keep going here for a little while. Dwarf galaxy survey. It's always nice. So they're using Spitzer and Herschel to find dwarf galaxies. That's cool. Training the delay time distribution of binary neutron stars. A new radio. Formation and evolution of multiple star systems. Kind of cool. Protostar masses. Mars obliquity history. Action-based models. Dwarf spheroidal galaxies and globular clusters. The tilt of the local velocity ellipsoid as seen by Gaia. The local velocity ellipsoid. Huh. Must be something to do with how local stars are moving. I didn't realize that they sort of fell into an ellipsoid. That's kind of interesting. W projection for wide field imaging. Wide field imaging, modern radio astronomy. Okay, cool. Yeah, radio astronomy sort of, I think inherently is pretty narrow field. Mainly because the detectors are basically 1 pixel in size. So that sort of limits your field of view there a little bit. A supernovae, the dust producer in the early universe. Time-resolved spectra. Gamma-ray bursts. Gamma-ray bursts, I think, are still sort of a mystery. So for sure, we need to continue observing those. Wow. Okay. Search for nearby Earth analogs. Okay. SkyMapper, SEDs. SED is that's some kind of a minimization algorithm, if I remember right. Fornax Deep Survey. Dwarf galaxies again. Everybody's really excited about dwarf galaxies. Convolutional neural networks. Neural networks are very, very cool. I need to get back into those a little bit. I worked with those, wow, 30 years ago. I need to get back into those a little bit. Line bin treatment of opacities. I'm not really seeing anything particularly grabbing here, but we'll keep going. Structured jets and X-ray plateaus and gamma-ray bursts. It's nice that these gamma-ray bursts are now sort of being observed. 20 years ago, they were extremely mysterious, much like the fast radio bursts are now. I still think that they're pretty mysterious. We don't really have a good grasp of them. Who's leaving us?
Good night, Ingrid.
All right, Ingrid. Yep.
It's
Take
about
care.
time for me to go too. I turn into a pumpkin in 5 minutes.
All right. Well, like I said, pumpkins are definitely not allowed on this live stream. So yeah, it's really, really nice that we're now observing these things. That's nice. Debris disk composition, emerger shock in Abell 1367. I wonder if that's okay, that's a cluster. It's I guess a cluster of stars, cluster of galaxies. Doesn't really say here. It says a dynamically young cluster, but I think the Abells are galaxy clusters, if I remember right. Let's take a quick look and see, because yeah, I think I'm gonna end the live stream here in the next 5 or 10 minutes anyway, because I've got to get out. I've got to do a sky alignment, and I need to if the wind isn't blowing anymore, I want to get on target ASAP. But let's just sort of see what this guy is here. Galaxy cluster, yes. So it's Abell 1367. I wonder if they have a at least a picture. Okay, they're looking at it in the X-ray. So it's probably, there might be some pictures here. Let's zoom out a little bit, see what this is all about. All right, so yeah, this is a X-ray image. Looks like it's got some contours on it, stuff too. So, all right, well, for what it's worth, this is pretty wide field. You can sort of see the scale here. So the radius of this circle is about 30 arc minutes. So this is about the size of the moon, the circle here. Actually, twice the size of the moon. So yeah, that's a pretty large piece of the sky, and it looks like they're sort of identifying a few objects in here, a couple of the galaxies. Kind of hard to see. I think that says NGC 3862, 3842. Let's just over here and see if we can look at NGC 3862 in the visible. 3862. Calling that a quasar. It's kind of neat. Okay. So we can get about the same field of view here. Oops. Well, see, that's a 32 arc minute field of view going all the way across there, and I think this is twice as large as that, right? Because this is 15, here's 30, yeah. So that's even. So this is a big chunk of the sky. Let's see if I can back up a little bit more here. So that's about on the same scale, and yeah, that's definitely a cluster of galaxies. Probably not all of them are members, but maybe they are. Kind of hard to tell. But yeah, this is on the same scale now, and looks pretty different. There's a lot of X-ray light right in the middle here, which I guess would sort of be here. Can't really. Well, I don't know if we're seeing stars here. If these points might be stars, 1, 2, 3. Because I'm seeing a star here. Yeah, kind of hard to tell. But yeah, I guess they're looking at different aspects of this cluster: temperatures, metallicity.
We're about to lose Alta.
About to lose Atta. All right, Atta.
Yeah.
Don't want to see any kind of pumpkin here. So have a great evening, and I will see you later. Thanks for coming in, for sure. All right. Well, there's that guy. Abel 1367. Type 2 Cepheids. Confirming C60. That's actually one of the buckyballs using the HST. Interstellar buckyballs. Pretty cool. Wonder how they're doing that with the HST, which means they're looking either in the infrared or in the visible, maybe the ultraviolet, towards 7 heavily reddened stars. So yeah, they're looking for C60 bands, I guess. Okay, so here are the wavelengths in angstroms. So yeah, pretty far out, well into the infrared, around almost one micron. So not incredibly red, but well beyond the sensitivity of our own eyes. So cool. There are these spectral bands that I guess C60 plus probably absorbs, and wow, it looks like they're actually seeing them. Let's see what those spectra look like. Diffuse interstellar bands. So they are looking at starlight and seeing these bands in the spectra, and sort of concluding that material, C60, probably isn't at the star, but it's between us and those stars. So that's pretty cool. Let's see if there's there's some spectra here. So, okay. So here's the wavelength in angstroms. Looks like it's going from about 9050 up to 9600. And the intensity. And this is for different stars. So instead of, trying to overlap them and all that, they spread them out a little bit so we can see the individuals. You can see a lot of commonalities. Here are some of the hydrogen lines, absorption lines. Helium. Looks like there's some nitrogen 3, some helium 1, some argon, all of that. But I guess these lines here are the ones that they sort of identified as being associated with carbon 60. And yeah, sometimes it definitely looks like there is something there, and sometimes not. Like here, I don't know if I see any evidence there at all. Maybe if you can believe that little dip there. But this one's pretty obvious in at least these stars. It's not showing up here. So, depending on where you're looking, you see different things. So, kind of cool. I wonder what these other lines are here. They haven't identified like that one or any of these. Not quite sure what those are. Cool. Okay, so here they've just sort of expanded on that a little bit and shown exactly what's going on. You know, these shapes, the widths here, and the depths and all that tell you lots of things about what you're looking at in terms of how much stuff there is. Maybe, you know, what kind of temperatures you're working with, those kinds of things. So, all right. Well, cool. Pretty amazing that we think that we're seeing this. It's you know, if you look at the intensity over here, this is sort of like a percentage. So you can see that these dips in the spectra are like 1% dips. They're really, 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 you know, hardly noticeable at all. Even these deep ones, right, are still maybe only like 5%. So, you know, not much there, but it looks like they've got some good signal here. So, I mean, looks pretty obvious. So, pretty nice. Pretty cool. Nice. All right. Well, I'm looking at the time, and yeah, I think I definitely want to get out under the sky. I want to see what the conditions are in terms of wind and all that. It is definitely clear. It is definitely dark. So yeah, I think I'm going to get out of here for now. So all right, everyone. Glad you could come in once again. It's always, always, always great to have you here. I will be back again tomorrow, 2 hours UTC, to cover more astronomy, more space, more science, and whatever else we like to dive into. So, all right, everybody, take care. Make sure to subscribe if you haven't already. Thumbs up if you like. Make some comments. Spread the word. Spread the word. And yeah, I'll be back here again tomorrow, 2 hours UTC, a little less than 23 hours from now. All right, take care, everybody. Hold on to your hats. It's a wild ride. Hang on. It's pretty smooth though, so I think we'll be all right. And I'll see you tomorrow. Peace, cheers, and all that. See ya. Bye.